Good morning, everybody.
Happy June 9th, Tuesday. Today, our goal is to be able to determine the area of regular and irregular shapes. Remember, regular shapes are shapes that have all the same sides. Irregular don't. So focus on that word area. Area is different from volume because it's talking about a flat surface. In my house, my mom used to call the rugs on our floor area rugs. It's how much space on the floor does the rug take up. So we're going to learn various formulas for various shapes like a rectangle, square, trapezoid, circle, and use those formulas to determine the area. To understand area a little bit more, we can look at number 1. How about Mrs. Talhami? And describe for them that area really is talking about how many cubes you can fit in a given space.
Actually, for
So,
area,
for example, on number 1,
for area,
not a cube.
it's actually how many squares. How many squares?
Yeah.
Mm-hmm.
So, do you know why Mrs. Talhami just corrected that word cube? Cube is 3D. That would be volume. But for area, again, it's a flat surface. So it's really how many squares. Squares are flat.
So if
it's 8 across and 3 down.
Yeah. So 8 going here and 3 here. So an 8 by 3 has how many squares? Now I could sit here and start counting how many squares. But you'll see we'll talk about the formulas in just a second, so that it makes our life easier. Instead of counting how many squares it fits. So this has 24 square centimeters. Or sometimes we write it centimeters squared. So that's why area is a squared unit, because we're counting how many squares are in the rectangle or in a shape, in any shape. So to help us, instead of sitting there and counting how many squares are in each shape, we could use the formula sheet. Now the formula sheet focuses on 3 areas. They give us a triangle, a parallelogram, and a circle. Now keep in mind that word parallelogram applies to many shapes. What's under the parallelogram tree? You have a parallelogram, you have a rectangle, you have a rhombus, and a square. So 4 shapes apply to this word parallelogram. Another one here is we have also triangle, okay, and we have circle. Now notice one shape that's not on here that we've discussed is a trapezoid. Now a trapezoid is not given to you. You need to know it, but I have a trick for you. Trapezoid and triangle both start with the letter T. So the trapezoid really has the same formula as a triangle, but there's only one trick about it. In a trapezoid, we have more than one base. In a trapezoid, we've discussed that the 2 parallel sides are base 1 and base 2. So you actually have to add the 2 bases so that you get the formula of the trapezoid. So the formula for the trapezoid is 1/2 base times height, but base is the sum of the 2 bases. You have to add the 2 bases.
Would you mind just drawing the trapezoid again, just to make sure everybody remembers what a trapezoid looks like with the 2 bases? So there are actually different trapezoids. Some have 2 triangles on either end.
I'm drawing 2 different kinds.
And either way you draw it, you still have a top and a bottom, the base 1 and base 2.
Now, it's not always the top and the bottom, but Miss Murphy said that because in both scenarios here when I drew them, the top and the bottom were the parallel sides. Whoa. Those are the bases here.
Yes, the parallel sides.
Okay, so let's see if we could use the information we have there and the information that Miss Murphy just explained about what the area is to find a few examples here. So the first thing you have to determine is what shape you have, or shapes if it's an irregular shape. So what shape is this here?
So this looks like a parallelogram.
So since it's a parallelogram, from the formula sheet, the area equals B times H, or base times height. So really we have to
So there is one piece of information here that's not needed.
Can you figure out which one?
If you said 12.2, you are correct, because the base is 30 and the height is always that perpendicular dotted line, makes a right angle with the base. So we're only going to be using 10 times 30, giving us 300, and a meter times a meter is a meter squared, or a square meter.
That's how many.
All of our area examples are always going to be squared units.
Yep. Because it's talking about how many squares, unit squares, fit inside the shape.
Okay, so here we have a trapezoid, just like Mrs. Talhami drew at the top.
So 1/2 base, meaning the two bases, times the height. So we need to make sure to focus on what pieces are my bases. These are the parallel sides. So we have base 1, base 2. Essentially, it doesn't matter because we're just adding them. So area equals 1/2 63 plus 47, and then the height has to be the perpendicular one. So this is times 37. And I'm sure Miss Murphy just grabbed her calculator.
I got 2,035 square millimeters.
2,035?
Yes.
Millimeters squared.
And I'm going to just double check my answer. 0.5 times 63, because you can use a decimal there. And then the height was 37. And yes, I got the same
And make
answer.
sure you use the parentheses. Parentheses are very important when you're multiplying. I'm sorry, when you're adding and multiplying. So you have to make sure that you add these two first before you multiply everything through. Or you could just write it in the calculator just as you see it here with the parentheses.
Okay, so here we have a circle. Area of a circle. We learned it as apple pies are 2. Because if you remember the circumference, that was cherry pie delicious. Apple pies are 2. Little trick here though, they give us not a radius that we need. They give us it goes all the way across. That's called the diameter. We only need half of that diameter for the radius. So half of 42 is 21. Okay.
Now, the problem does not tell us to round. So we want to first leave our answer as an exact answer, which means we should not be plugging in pi, because pi is an irrational number. But we do need to find out what 21 squared is.
441.
So we get 441 pi meters squared. Now, if they asked us to round it, we can plug in 441 pi in the calculator. And what do we get?
1385.44, or just 0.4.
So that's
Nearest
approximately.
10th, nearest 100. Yep. Remember that little squiggle means approximately.
So really,
Notice in number 1, even though we counted all the squares, there was 8 and a 3. And remember, it's a parallelogram. A rectangle is a parallelogram, which was just really base times height. So the shortcut would have just been 8 times 3. And we still would have gotten 24 square centimeters. Much faster than counting.
absolutely. So let's take a look at some of the irregular shapes so that you could see what to do when it's not just one formula you're using. And I'm just boxing off the answers here so that you can check them out later. So I think let's just do a couple more together. So like, for example, let's do number 5. So if we look at number 5, what shapes does this have in here?
So there really are a number of ways that you could cordon off different shapes. When I look at this, I'd like to go vertically instead of horizontally, giving dashed lines, and create 3 rectangles.
I agree, because if you go horizontally, not that it's wrong, I'll just show the difference. If you go horizontally, you do make more shapes for yourself. So I like to go the least amount of recognizable shapes possible. But that's a preference.
Plus, using the information they give us, we already know that the height is 10, and we know that the base of each rectangle is 3, because all of those markings we know indicate the same length. There we go. So maybe we can color in each one as we do it with stripes or something.
Sure.
So the first rectangle is base times height, which is 3 times 10, giving us a total of 30 in the first rectangle. And then the middle rectangle, we need a base, which is 3, but now we have to do a little bit of work to figure out the height. So, from the top to the bottom is 10, but we do need to subtract 2 3s.
So this
We need to subtract
whole
6.
entire thing is 10. And I know this is 3. And I know this is 3. So far that's 6. That means this piece right here has to be 4.
And now we have our base times height. 3 times 4 is 12.
I'm just showing all the work so that you know where everything came from. I'm just going to circle it so we don't get it confused. Is it too much
And what's
writing?
nice,
Do you think that's too much writing, Miss Murphy, or is it okay?
I think that's fine. I think that third rectangle is the same as our first. Base of 3, height of 10, giving us 30 square centimeters. But now we need to find the total of the shape. So simply add all 3 amounts, giving us 72 square centimeters. It's like a puzzle. It's kind of fun.
So I think that's pretty fair, and I think the rest of these are also pretty doable.
Yes.
Okay, so you agree with that. Now let's start looking over here at this next page. Now, in this next page, you have also some other types of shapes involved here. So let's take a look at number 13. Okay, so we have a parallelogram. Do we have the base and the height?
Well, I think given the information that's given to us, we could figure out that the base is the sum of the 5 and the 15, which is 20. But they don't give us a height measurement. So we're going to have to figure that out. Luckily, they do give us an angle of 45.
So that means in this little triangle, Miss Murphy, if they give us that 45, and this is a 90-degree angle, then this must be a 45, 45, 90 triangle. Huh, what do I know about these two legs since there's two angles congruent? What do I know about the two legs here?
They are also congruent.
So
now we know that our height is 5.
Yeah. So that
really helped to know our special triangles, Mrs. Talhami.
Absolutely.
So 5 20s is 100. Square centimeters.
Okay, so you might have to do a little extra work on the side. You may see that.
You might have to use the Pythagorean theorem. Some people might choose to use SOHCAHTOA, maybe other special right triangles.
Let's do another one that has another special right triangle. So if you look at this, this is also parallelogram. So your instinct is to say, hey, base times height. But please do not think that 8 is your height, because it is not. It is slanted. So 30 is my base, but now we got to do some extra work to find the height here.
Remember, a height must be perpendicular.
So I'm going to kind of blow that picture up a little bit here. Is that okay?
I think that would be very helpful.
Okay, so we have a 90-degree angle. We're trying to find this height. We know this is 60, and we know this is 8. Now, how does that help us? What kind of triangle is this?
Well, we have a 90, we have a 60. That must mean that our missing angle is 30. We have a 30, 60, 90 triangle.
And do we remember the rules?
Well, one angle is twice the other.
So we've always said opposite the 30 is x, and opposite the 90 is 2x, and then opposite the 60 is x rad 3. So let's see if we could fill in the pieces here. So if I know that opposite the 90 is 2x, and it ends up being 8, then what does that mean?
That must mean that 1x is 4.
Exactly. So opposite the 30 is 4, but that's not the piece we want. We want what's opposite the 60, which is x rad 3. So that must mean since x is 4, the height is 4 rad 3. A little bit of a challenge there. Now, when you multiply, this is one key piece of information that we've discussed. Anything outside a radical gets multiplied with anything outside the radical. Since this is inside the radical, you don't multiply with anything because there's nothing else inside the radical to multiply it with. So you just do 30 times 4.
So we get 120 rad 3. Centimeters squared.
And that's the exact answer. If they wanted us to round it, we actually have to do 120 times rad 3. And we'd get approximately
207.85 if we rounded it to the nearest hundred.
But again, the question did not ask us to round. I'm just giving you an example if you had to round. So really, this shouldn't be so bad because you're really thinking back to, elementary school, middle school. You've done these kind of stuff before. It's just now adding in some extra pieces. So do you want to do maybe 1 or 2 more, Miss Murphy?
Yeah, well, let's do 19 together. 20, just quickly, when we glance at number 20, yes. Hopefully they're going to see that 20 has 2 shapes. If you kind of look at it sideways, I'm seeing a half of a circle, semicircle, And I also see a trapezoid. So I think that they can do this on their own as long as they really recognize that there are two distinct shapes there.
Yeah, as long as they can catch that, like you said. Half a circle and a trapezoid. Or if they don't know how to do the trapezoid, they could also cut it into a rectangle and a triangle. That's also, possible.
Yes. Mm-hmm.
Okay, so then I guess they can do 20. So I guess we discussed it. We'll just go over 19 then.
Yes.
So here we have a circle, but do we have the full circle?
No, we don't.
No. So we know the area of a circle is pi r squared, but we have to put some fractional amount in front. Now, we don't know exactly what fractional amount, but what's the only piece of information they gave us?
Well, we know that the radius is 9. That's
Right.
one piece of information. But we're also given a degree measure.
Now we have 120 degrees. Now that's compared to what if we had a full circle?
So 120 out of a possible 360.
So that's
120
actually,
divided by 360. We could reduce that.
so we could reduce it. Now if you knew how to reduce it, you could easily simply do that in the calculator. Or you could just write 120 over 360. That's the fractional amount. So when you reduce it, what do you get?
A third. And it does look like a third of that pi.
Of pi times the radius squared. Now remember, if I want the exact value, I'm not going to put pi in the calculator. I'm just going to do 1/3 times 9 squared.
So a third of 81 is 27 pi.
Now, and that's approximately how much?
So we would do 27 times pi and get 84.82 square centimeters. That would be to the nearest hundredth.
So we've been rounding 2 decimal places, which is great, just in case, but we're boxing off the exact answer. So we have other examples here for you to try on your own. I think you may, there's a couple that'll be a little bit more challenging, but we can go over with you later. But for now, do your best and come back in just a bit to check your answers. All right, so hopefully you had a chance to complete the problems. We have all the answers here for you, so I'm going to zoom in while you check your work. Everything has been color coordinated and labeled.
Pause the video as needed.
This one you just have to recognize, even though it's a little slanted, this could be the base and this is the height because there's that 90-degree angle. It's really important to know how to find the area, Miss Murphy, because a lot of times people do use area when they're doing projects in the house. Like if they're trying to build something in their backyard, like a pool, and they want to try and, figure out how much space they need in the backyard.
Carpet layers, installers, tile installers.
When you say carpet layers, I think of, you ever heard the Empire commercial?
No, what's that?
The people who lay out carpets, their jingle is actually very catchy. It's like 800-588-2300 Empire Today.
Be careful. Hopefully YouTube is not going to
copyright this one too, right?
Talhami got in trouble for us playing that song,
the Seasons of Love song last time.
Seasons of Love, on our last video.
I hope they don't take the video down. I disputed the claim. Let's see what happens. Oh, we did this one together.
Just having a little fun.
Okay. And there you have it. That's how you find area of regular and irregular shapes. Hopefully you find this easy and we could finish off the year on a nice easy note. We only have, after today, I believe 4 more A days. And really, that's it. Just hang in there. Have a great day, everybody.
Bye.